This is my freeze dryer project, and today I'm going to try and get the system that can go below minus 50 Celsius, because I know a lot of cheap freeze dryers do not go below about 45 Celsius if you're lucky. So I want something that can go colder, primarily minus 60, but we'll see. So I've got a temperature sensor here. This is on the heat exchanger, which is attached near the capillary tube. So this is going to measure the CO2 side, the low stage. The high stage is here. I haven't got any sensors on that. The only place I can get an indication of that is here, where the second stage CO2 comes out the heat exchanger, so I know the temperature that the liquid CO2 is at, if it gets to a liquid state, that is. Depends how cold I get it. That's going to display on here. It's 20 at the moment, and obviously that's 19.6 there, so all within a few points of a degree. I've got low side and high side on the CO2, so let's get the high stage started. Right. Now let's try it again. Success. So the first stage, just for test purposes, obviously, this is just an old dehumidifier unit. The pump's not really powerful enough. I'm not even sure what horsepower that pump is. I'm pretty sure it's like 3/4 horsepower or something. But anyway, it's got good airflow over a small condenser. Picked up with a fan and sight glass. Sight glass is pretty useless, just gives me a rough idea as it's on the capillary. But it just gives me an idea, that, because obviously I don't know what charge to put in this. So this charge is a 407. Just they use a lot of units in refrigeration. So that is then running along here, which even I'm now getting confused with my own setup. Right, I'm back. Right, comes out the capillary, goes through a very small capillary, which is about 1 meter long, into this end of the heat exchanger, which is basically a 1/4 inch tube running through a 1/2 inch tube. That then runs through this length of pipe, which again is about 2 meters long altogether. That then pops out the end here. As you can see, it's already icing up, where you have your CO2 side on the high pressure, this is. And then this is the suction line returning back to the compressor. Again, a complete and utter temporary setup, so ignore the length of the excess length of the tube. I just didn't want too much frost back, which I do and I don't. Right, okay, so I'm just waiting for that to come down. That's at 14.5 already, so that's at that point. This line here is more like minus 30. It's already starting to frost back. And it is actually dropping the temperature over here as well, which is so that it's already pushing the refrigerant, the CO2, through the tube and into this stage when this isn't even turned on. It will also drop the pressure, which we will get up in a sec. Just check that all these lines are secure. Right, I'm going to open up the high side. Now I charged this with about 150 psi of CO2, because none of this is rated for, none of this is for CO2. The idea is CO2 sits at about 150 psi. Just opening up the low side. Right. Now I have put a bit of R290 in with this CO2 because it does help stabilize it, I found, because I was getting a lot of frost, a lot of dry ice forming, which I believe it's dry ice forming at this end, at the capillary end, as it was going into the chamber because of the low suction pressure. But the R290 seemed to help stabilise that. So we're getting a lot of frost back now. I'm gonna start this up. It's at 7.9. Realistically, I'd want this to be like -30 on the CO2 side. It will be over here, but I would have liked it to be -30 at the actual sensor end. But we're not going to get that because it's a crude setup. It's literally just for testing. I just want to see if I'm actually going to get a decent temperature with this setup. So I've now just started the compressor. This is off an old pool heater, heat pump. It's for R32. But I know these operate at a little slightly higher pressure, so I thought it'd be brilliant to use on the CO2. Anyway, as it rises, we've got 217 on the suction, and you can just see that temperature fly down. So we'll see what we get. And now it's pushing it through. It's at -15, which is still not great, because if you look at a PT chart for CO2, that doesn't liquefy at that pressure to that temperature, which I don't think is a disadvantage. But it does seem to be working, because we wouldn't really be getting any sort of temperature jump, I wouldn't have thought, if it's not some sort of liquefaction isn't happening. So far, that is not impressive. The strange thing is, I've had this system, I've been fiddling around this for a while, and that's dropped straight down to -55 before, with not much trouble. I seem to get slightly different results every time I turn it on. I mean, sometimes it sits at 300 psi, and this will be at 40 psi. See, I've got frost back already. Again, sometimes I don't get frost back, sometimes I do. I have the last couple of tests, which I don't mind because this compressor gets hot. It's going to be no good for using as an actual on my freeze dryer, because unless I sort out the heating problem, because it's lovely and cool at the moment. It may stay cool now since it's getting liquid refrigerant straight back to it. A lot of that could be the R290 coming back through, which in a way I want. I need some cooling within this pump because CO2 has quite a high compression heat anyway. Again, those results, I can get so far we can get similar results with just a single stage at the moment, so that needs to do far better, which I have got it far better, so I don't know why we're not getting very good results right now. You can see it's starting to take a lot of heat out the first stage. So I mean, and the frost back has started to pull back from the first stage compressor. I mean, my opinion, this is just not man enough. I mean, realistically, you'd have a more powerful compressor on the first stage, but I don't want to go. I've got much more powerful compressors, but I'm not using them on a test rig. This is literally just for testing. I just want to see if I can use cheap CO2 to get a good cold condenser on the freeze dryer. Because if we can get minus 50, minus 55, it's already a step ahead of most other freeze dryers, and we're going towards the more high-tech ones, which you can do a lot more with. Realistically, you want minus 80 with them, minus 85. We're not going to get that because those refrigerants that they use are just ridiculously expensive in the UK. So R508B, I believe, £8,000 for a bottle. I'm not paying that. If anyone knows where I can get it cheaper, please say in the comments, because that would be a great help. Because I wouldn't have to bother with trying to test a lot of CO2 refrigerant. The other problem I have is obviously, can I trust the actual instruments sometimes? I mean, as far as I know, that sensor is tight against the pipe, but I mean, I was using a different sensor before and I got minus 57, but was I? It's quite warm. Amps. We'll check the amps on the compressor. Make sure it's not working too hard. That's working a bit hard. I've had that at 1.8 before, and it was running at 300 psi 1.8, so there's something going on there. It's probably maybe because the oil's not so warm, it's not as well lubricated. The other problem I got with this is obviously lubrication. I mean, where we're working with colder temperatures, is the lubrication getting round? Is this pump being starved of oil at the moment? Doesn't feel too hot, but it will get hotter. So the way this works as well is this is going out this pipe here into this condenser, which I've got this pipe blowing cold air across, out of here from the discharge pipe, which is just warm there. That should be hotter. And then into the heat exchanger, which you can see is frosted up. That then runs round to there, then goes in a capillary, again about a metre long. See that capillary is frosted. That then goes down to this point, which then goes into the evaporator, which I've got coiled up here for testing purposes. See, this result's rubbish. I was getting much better results earlier, so once again it's changed. If anyone can sort of help me out, it would be great. So finally hit 50 Celsius, that is. The compressor's not actually as hot as I thought. That's pretty standard operating temperature. Could actually probably get a little bit hotter, to be honest. But I think it's only staying that cold because, well, that warm, because there's a lot of frost back on here. It's at 300 psi now, 12.4 on the suction line, and it's pretty stable. I mean, without the R290 in it, I was getting, that was fluctuating all over the place. As I assumed dry ice was forming, but the R290 seems to really help stabilise the system. I'm also, it's still dropping, which is good. The capillary has been wrapped around the suction line as well to help pre-cool it even further. But I have had it colder than this, but this is stable. This seems to be running quite smoothly like this. When I had it colder than this, it was a little bit erratic. So it may be best to, I'd prefer it stable and slow than erratic and don't know where I'm at sort of thing. But this is already, considering this is Celsius, this is already surpassing the temperatures that you'd get with like a harvest rate freeze dryer. But it's certainly not near what you would get on a commercial freeze dryer. But I'm very happy. If it, depending on what it gets down to, which I imagine it will be about 56, that is pretty good. But question is it going to be that much more performance over how much more power I'm going to be using? Is it really going to speed up the process of freeze drying that much and make the product that much better to make it worthwhile having an extra compressor running? Because this is double the power consumption basically, and these freeze dryers, they use a hell of a lot of power. I am planning on using the excess heat from the discharge lines to heat the trays in the freeze dryer, so we're not having to use electric heaters, which is a big cost with them. And I'm interested to find out as well what would happen if I got a better compressor on my first stage, on the high stage, because as you can see this is coping well, but it's certainly not pre-cooling it to the temperatures that I would like. This is another thing that confuses me. 300 psi at minus 7.3, I'm pretty sure on a PT chart that is not cold enough to liquefy CO2 at 300 psi. So I'm assuming it maybe in between, sort of. That's why it's working. Certainly I know it is working, it's doing something, because obviously if I turn this system off, this pressure shoots up. You can't, and I've tried running it with this off just to see what happened. literally you get -3, and it struggles. And I believe that's literally just the R290 doing its thing. It's got nothing to do, the CO2's just doing nothing in there. But it certainly is doing something when you pre-cool it. But I just thought you would need to pre-cool it a lot more than -7. But yeah, that's starting to get down cold, a bit colder. I'd like to keep this going, but the compressor is slowly getting hotter. I mean, one other thing is I may try removing some of the CO2 and R290 to reduce the pressure and just see what happens. Let's see if this temperature changes for the better. So I've vented a bit of CO2. That's the great thing about CO2. You don't need to follow any strict regulations with CO2. Obviously, just confined spaces matter, which I'm actually in, but I've got fresh air blowing in, so I'm not too concerned. And it's 238 now. It's still gone down to -53.1, and the amps is now 1.8. Still got frost back, so then the pump's still staying, well, the compressor's still staying relatively cool. It is getting hotter all the time. I mean, I won't keep it running too much longer because I don't want to. But one thing that did change is I've got I've got a lot more pre-cooling now on the first stage. So the pressure drops definitely helped with that, and it hasn't seemed to make much difference to the temperature. It's still dropping. So I don't think we needed quite as much in the system. So that's probably more like, probably settle around about 140 psi in that system now when it's turned off. Just the lower I can keep the pressure, the better really, the safer it is, because as I was saying, none of the components here are designed for a CO2 system. Normally you would have to make these things out of a slightly thicker, slightly better gauge copper and all that, but because I'm using it as a cascading system, I don't believe I need to do that, because I'm not having high pressure CO2 sat in there all the time, and I believe it would take a lot of heat to get that to pop. And like I said, if there's a fire or something, it's going to pop regardless of what's in it. I mean, I'm pretty happy with these results now. If I can just get a bit, I reckon it could just be oil return that's causing this to get a little bit hot. And again, on a proper system, I would put a oil return onto it. Slightly bigger first stage again, get this down to -30, see what happens. So yeah, I'm pretty happy. I'm gonna transfer this concept now onto my new freeze dryer.